Hello everyone, we are from Team 3. Today in this presentation, we are going to explain the research report of COVID-19, which is the lastest one. And these are our team members. And in this presentation, we are going to discuss about the classification of different algorithms with respect to the COVID-19 data. Can you please go to the next slide? And these are the contents we are going to discuss in this presentation. One is the abstract, introduction, material and method, like supervised machine learning model and its methodologies and the result. Conclusions and its references that we have used for this research report. Next. When it comes to the abstract,
Just a moment.
and the introduction, when it comes to the abstract, it will be very easy in the report. Can you please go to the report? This is our project report. Here in this abstract, we can see that the COVID-19 data landscape in India, we have faced a lot of challenges in managing this pandemic that has utilizing of many data resources and machine learning techniques. And our aim is to provide a comprehensive analysis of the situation. Here, we begin by examining their age groups by affecting this virus employing various machine learning algorithms. And here the random forest algorithm emerges as a standout performer in both the regression and classification tasks, outlining other algorithms such as SVM, KNN, decision trees, and more. And this predictive model developed offers insights into the impacted rate, daily new cases, and daily total completed cases, and the light of the pandemic's tragedy. And furthermore, we also have conducted the multi-class classification analysis of COVID-19 data in different states of India, focusing on confirmed death and the queued cases. Through this data cleaning, feature selection, and the k-fold cross-validation, we ensured the robustness of our random forest model, which consistently used for the other methods. And our research mainly provides a holistic understanding of COVID-19 in India, contributing to a global knowledge based in the health crisis. And can you please go to the PowerPoint? As we have also discussed in the abstract, here we can also resolve without the need for medical intervention and the virus that poses a significant threat to other individuals. And this is the data we have extracted, like many death cases and the confirmed cases. Next slide. As we have discussed earlier, and these are the machine learning algorithms, we are using it when it comes to the material and method. In India, this virus was reported in January 13, and these machine learning algorithms, which rely on data-driven models rather than explicit programming, offer a valuable approach to understanding and predicting these trends. And this study evaluates various regression models, including least absolute linkage and the selection operator, decision tree, linear regression, random forest, and polynomial regression, and according to this data. Next slide. When it comes to the material and method, here we are just discussing these definitions. When it comes to the supervised machine learning model, in this study, this machine learning model is employed for forecasting these cases, and that are trained in a labeled data set where each data point is associated with the correct answer. And our main goal is to learn from the labeled data, which gives us predictions on new and the unlabeled data. The 6 regression models that we are going to discuss. One is the lasso. Here we can see this is the statistical regression analysis tool that not only enhances prediction accuracy but also performs attribute selection and validation. And it is also originally discussed for linear regression but can also be used for other types of regression. And this is also used as a penalty term. Here we can see the definition, like A of k represents the observed responses, and the first part of the equation represents the residual sum of squares, and this second part represents the penalty for having non-zero coefficients. Next slide. And the SVM algorithm, this is also used for the regression tasks. This works by transforming the input data into a high dimensional feature space using a non-linear transformation. And this SVM algorithm performs non-linear regression by transforming the input data into a high dimensional feature space using a kernel function. And the goal is to find the parameters B and C that minimize the prediction error. When it comes to the algorithm, g of x is equals to y of beta plus c. Here y of is the distance from the value, and the beta represents the slope or the gradient function. C is the value of x, and where y is 0. Next slide. When it comes to the decision tree regressor, here we can see this algorithm is basically the splitting of the data, like decision nodes. We are splitting the data into decision node, and then the decision node is split into different types, and it continues as follows. When it comes to our data like COVID-19, here we can see like 71 patients, 89 patients, and further they are classified into 60 and 11 patients, and these 60 are classified into 39 and 21, and then they are classified into 32 and 7 patients. Here we can see the high risk and low risk, and we can also see the age differences, everything. Next slide. When it comes to the linear regression, it is a fundamental statistical method used in machine learning that establishes a linear relationship between the independent variables and the dependent variables. And our main goal is to find the coefficients that minimize the error between the predicted and the actual values. Linear regression is commonly used for predicting the numerical values. And our main goal is to find the values of theta 1 and theta 2 that minimize the error term and that provide the best fit in regression line. Here we can see the definition, like y is equals to theta 1 plus theta 2 of x plus error term. Theta 1 represents the intercept and theta 2 represents the quotient of x. Can you please go to the report so that we can see the results of the different algorithms? The first algorithm, lasso. Here we can see the algorithm that we have already explained in the presentation. When it comes to the SVM algorithm, we can also see this is also explained there, and the decision tree that is used for splitting of data, and the linear regression. Next, the random forest. Can you please go to the PPT? Next slide. When it comes to the random forest, it is a assembled learning algorithm that combines multiple decision trees to improve predictive accuracy. And it works by training multiple decision trees on various subsets of the data and averaging their predictions. And this technique often results in more robustness and accurate predictions because it has the risk of overfitting and accounts for the complexity and unnecessary inherit in pandemics. By averaging these predictions from multiple trees, this random forest algorithm has also proven that it has the more robustness and accurate forecast, considering the various factors influencing the spread of viruses. Next slide. When it comes to the polynomial regression, it is also a regression analysis technique that models the relationship between the independent and dependent variables as an nth degree of polynomial. And it allows us to record nonlinear trends and inflection points, which helps us to forecast more accurately and comprehend how differently treatments and outside influences might affect the pandemic. Next slide. When it comes to the methodology, here we are first using the COVID-19 data, and then we are data processing it, and then we are splitting that data, and we are training those data with these algorithms that we have discussed earlier, like SVM, lasso, decision tree, random forest, linear regression, and then we are evaluating that model with some descriptive analysis like mean, absolute error, root mean, square error, and these errors. And also then we are finding the results and analysis that will be discussed later in this presentation with the graphs and everything. Next slide. If you can see the comprehensive analysis of our report, here first we are taking the COVID-19 data, and then we are pre-processing it, and then we are splitting it, which is and then we are testing that data. We are training that data with these models, and then the trained model is then evaluating with these parameters. This is the proposed flow chart that we are using in this report. When it comes to the results and discussion, this will be discussed by my friend Karthik.
Thank you, Shravya. Yeah, results and discussions. Coming to results and discussions, earlier in our data set, we used like a couple of results. We've shown the accuracy final results in our whole report. So coming to the results, like the West family of known as can be the both people like in the animals, numerous and coronavirus. The main aim of this report, like combining the severity from the COVID-19 report. Here we can see the name and the description of our title, Union Territories, and the Indian National description feature of this prediction, how the algorithms predicted the accuracy and given the best results for the report. And the Minister of Health Family Welfare has we taken the data set from the Kaggle. Actually, these data sets are uh, mainly used for the couple of states in India where the cases are followed up and where the results exactly the virus spread over there. We exactly review those all from this data set. Evaluation of parameters. We used a couple of parameters here. With this parameter only, we got the best results from those algorithms like a random forest linear regression and also lasso. This is the first parameter we used in our report, like a R square. The R square is a strength of the relationship between the dependent variable and also the regression model. It provides a value between 0 and 1. So the value between the 0 and 1 and also the mean variation between the both models, it explains the all variations. You can see the formula here, R square equals to variant of a model by total variance. That means a higher R square indicates a better fitting model, like value of model divided by the total variance, how much variance we got in this actual algorithms. So R2 is defined as a percentage that the independent variables and also it facilitates the evolution of the model's quality. And the mean square error is the second one, MSC. The MSC is a measure of the average. We can find the average using the measure square difference between the predicted value and also the actual value. It quantities the equation between the errors and also the predicted formulas. Like MSC is equals to 1 by m equation square of y1 minus yj. These are the parameters we used, where m is the number of observed points, like how many cases of the observed points, how many uh, uh, issues as attempted in the Zoom model predictions, like that. So the actual value of y and j will calculate the larger errors and also prove the equation perfectly. Like these also provides some suitable regression problems and also provides a clear interfered metric, like that. Coming to next slide, this is a third one parameter. We used mean absolute error. This we're finding the mean absolute, where the error another measure of the prediction error and the average of the absolute differences between the actual predicted value and also formula. We can see the MA is equals 1 by m. It is quite similar to the second one here, mean square, but this finds mainly the average absolute error. So how the average going to done with the parameters and the does not square. Okay, we can see in our report, like how the actual results is done it. This is a gradient square. We taken this model performs the mean square MSC relationship of the data and also minimize the MSC state differently. And also it penalizes the larger errors more lively squaring. It is suitable for the regression models. Mostly it's suitable for the regression models and also suitable for the some issues in uh, mean error values. So mean absolute error is nothing but like we can see it is quite similar to the mean square, but it is different in the average absolute, how we can find the average in the errors and also give the appropriate total error. And the final one is the root mean square error, RMSC. We use the root square for this algorithm. Sorry, for the couple of algorithms we used, like linear and random. For those algorithms, it finds the absolute um, square value and also gives the estimated value, like the how many people's of cases is involved in the COVID-19 pandemic time. Those reports shows here clearly. And coming to the results, the study of the statics, including the active death cases and the recovery rates, and there are also models are used to train the data set, and it gives perfect accuracy for that. And you can see the active cases also forecasting. This is our actual model accuracy, like how the parameters has worked and give the best results as 98 and 98.64. In these are the polynomial less one, polynomial linear regression, decision tree, random forest, so support vector mission. These all are come see mainly the polylinear linear regression are the highest one, because these are mainly considered as a regression things. They give the better result to applying any algorithms in machine learning. So um, after that, we can see the graph of the active cases, recovery cases, and case prediction data, and also the random forest shows the linear, random forest and linear shows the graph of high on the scatter plot. We can see the graphs here little bit. And this is the actual accuracy, and these are the mean values and square values and the square root values, like that, of death cases and recovery cases. This is death rate forecasting. I mean, how many people died in this COVID-19 scenario? That time it shows the all algorithms accuracy, how many people died at that situation. So the graph also using these main algorithms, it shows the exact gradient and another parameters. And this is the third one, recovery rate forecasting. You can see the recovery rate forecasting, how many cases recovered from the COVID-19 pandemic time. Then decision tree and random forest models are mainly used in this recovery forecasting because they shows the absolute error and absolute values which can be finally set into the algorithms in machine learning. So these are the results of the recovery rate forecasting. And this is a graph of results of recovery forecasting. So coming to our PPT, these are active case forecasting I've shown in the report earlier. And these all are graphs and death rate forecasting. Some scenarios Lasso is shows gives very less prediction because of death rate. The mainly decision tree and random forest provide the best results. Not all the algorithms, but decision tree and random forest give the best results for. So that's why the Lasso is in little bit down. And these are the graphs of recovery rate forecasting also. This is the final results of here we can see the random forest giving 99. So highest accuracy root square, and these are parameters of how many people's death cases and active cases, those all things. These are the graphs you can see prediction by Lasso. Coming to our conclusion, actually, this COVID-19 pandemic has posed a significant global crisis, also potentially impacting a large portion of the world's population. So, governments and researchers worldwide are deeply concerned about the implications. In this, machine learning approaches to predict the spread, to predict and spread the COVID-19 global level. The dataset contain we researched from couple of data sets. We taken the couple of research papers in COVID-19 active cases and problems in that particular um, scenario. So we can collect the all information here and rectifying using these machine learning models like all the algorithms earlier. Strav explained clearly about the all algorithms. Those algorithms are mainly effective in the prediction. So they give the best results and the parameters which we used in this report that are given perfect results to us. And also this report shows us mainly the additional other models such as linear regression, decision tree, and random forest also promising results in forecasting, and also the data which we collected. And it is evident that the death rate and also recovery rate is promising results, not a junk results or a copied results.